All right, let's get right onto it. We're always hearing about the next big AI model, right? But today, we're looking at something from LGAI research that promises to solve one of the biggest headaches in artificial intelligence: how to make an AI that can think both fast and slow.
See, that's the fundamental choice we've always had to make. Do you want an AI that spits out a quick answer for a simple question? Or do you need one that can really, sit and chew on a complex problem to get it right? Usually, you got to pick one or the other.
But what if you didn't have to? What if a single AI could be both? Imagine if it could just switch gears, going from a quick thinking mode to a deep thinking mode, depending on what you ask it. Well, that is the big promise behind a new model called Exaone 4.0. So here's how we're going to break it all down. First, we'll talk about that AI speed dilemma. Then we'll introduce Exaone 4.0 and its really cool two-in-one model. We'll peek under the hood to see how it gets so smart, and then, of course, put it to the test to see how it performs. We'll wrap up by looking at what this all means for the future of AI.
All right, first up, let's really dig into this core conflict, this trade-off that has been a real challenge for developers for a while now.
You see, it all boils down to this. Building an AI that's great at rapid-fire conversational answers is a totally different beast than building one that can, say, patiently work through a multi-step calculus problem. So users and developers, they often have to settle for an AI that's good at one thing but not the other. And that really limits how versatile these tools can be.
And this, right here, is where our story really begins. Exaone 4.0 from LG AI Research steps onto the scene, and it was designed from the ground up to solve this exact problem. So at its core, Exaone 4.0 is not just another LLM. The absolute defining feature is its unified architecture. It literally combines two different ways of thinking into one system. You've got what they call a non-reasoning mode for speed and a reasoning mode for depth. The team at LG had a pretty clear mission here. They wanted to take the best parts of their older models and merge them together, but they also wanted to give it new powers like being able to use tools. Plus, they expanded its language skills and are offering it in two different sizes for all sorts of applications. Okay, so let's get into the main event, this whole two modes in one thing. What does that actually look like, and how in the world does it work? I love this analogy. The best way to think about it is like having two different athletes on the same team. You've got the sprinter. That's the non-reasoning mode. It's all about speed and efficiency, perfect for quick chats or getting a fast summary. Then you have the marathon runner, the reasoning mode. It's built for endurance. It takes its time, thinks deeply, and solves those really tricky problems with way more accuracy. So having two modes is a brilliant idea. But how do you actually pull it off? Let's take a look at the secret sauce that gives this AI such incredible flexibility. Okay, I know this slide, it looks super technical, but just ignore the text for a second. The key idea here is something called a hybrid attention mechanism. The easiest way to think about it is like a camera that has two lenses at once, a wide-angle lens to see the big picture and a super powerful zoom lens to focus on the most critical details. By using both, the AI can process information with incredible efficiency. And believe me, it needs all that efficiency because look at this number. We are talking about a 128,000 token context window. To put that in perspective, that's enough to read and understand an entire novel in one go. It lets the AI grasp really long, really complex documents or conversations without losing the plot. But a cool architecture is only part of the puzzle. Its intelligence really comes from a very specific and intense training process. Now, this diagram looks like a crazy flowchart, but the big idea here is that they didn't just throw a bunch of random internet data at it. This is a sophisticated, multi-stage pipeline built to teach it how, and more importantly, when to use its different skills.
Let's just walk through it real quick. It's basically a 5-stage boot camp for the AI. It starts with general fine-tuning, then it specializes in writing code and using tools. After that, it goes through some serious training to beef up its reasoning skills. And finally, it goes through 2 rounds of learning what humans think a good answer actually looks and sounds like.
All right, so the theory sounds amazing, the tech is cool, but the real question is, does it deliver? Let's see how EXO1 4.0 actually stacks up against the competition when the rubber meets the road. And wow, this is where things get really impressive. When you look at a benchmark for advanced math, Exaone 4.0's reasoning mode actually scores higher than another major model that's quite a bit larger. This just goes to show how effective that specialized deep thinking mode really is. And it's not a one-trick pony either. It's not just a math whiz. When they tested it on general world knowledge, you can see it's right up there, neck and neck with the other frontier models. This proves it's a seriously well-rounded and capable system.
You know, you don't even have to take my word for it. The researchers themselves sum it up perfectly in their paper. It basically punches way above its weight, outperforming models its own size and even hanging tough with the giants of the industry. This unified approach really, really works.
Okay, so let's zoom out for a second. We've talked about this one model, but what does it all mean for the big picture? What are the broader implications here for the future of artificial intelligence?
The main thing to take away is this: we're moving beyond one-size-fits-all AI. These unified models are a huge step towards something called agentic AI. And that's just a fancy term for AIs that don't just answer your questions, but can autonomously figure out the right tool, or in this case, the right thinking style, to get a job done. And that makes them infinitely more capable and useful in the real world.
And that's really the thought I want to leave you with. We are now building AIs that can decide how to think for themselves, switching between that fast, intuitive sprint and a slow, deliberate marathon. As this kind of technology gets better and better, what kind of massive real-world problems do you think they'll be able to solve next?